if we want to find the relative extrema that are maxes or mins and the points of inflections or inflection points, this means we have to take the first derivative, set it equal to 0, and then check to see if they're maxes or mins. This is saying take the second derivative, set equal to 0, and see if they change inflection, meaning they change concavity. We're going to refresh old stuff. So, for this we need first derivative, which this isn't that bad of a first derivative. Derivative of x is 1. Derivative of ln x is 1 over x, which, okay, and then let's get y prime just right now, because we're going to need y prime in a second, so let's just do it. Derivative of 1 is 0. Derivative of, wait a second, 1 over x is a negative first. You guys got that? Let's go over here. If we were to rewrite this, x to the negative first, when you derive that, brings a negative 1 up front, becomes negative 2. So it would be negative 1 over x squared. But there's a negative in front, so it's 1 over x squared positive. Does that look right? When you take this negative 1, put it in front, subtract 1, be negative 2. It'd be a negative, but the negative in front makes that a positive. So that's your first, that's your second. Now, to set the first derivative equal to 0 for extremas, do I first need to get a common denominator? So I'm going to rewrite this one. Y prime, multiply top and bottom by x. Is that okay? These are the same. So, x minus 1 over x equals 0. Got to pull back those old thoughts we haven't done for a while. To find the critical numbers, we set the top and the bottom equal to 0 because where the derivative equals 0 or does not exist. It's been a while. So there's 1, and what's this one going to give you? When you add the 1 over, you get 1. So these 2 points are where you have critical numbers. Does that mean you have extrema there? No. That just means they're critical numbers. Those are critical numbers. Now let's check to see if they're maxes or mins. So to do that, we can either do the second derivative test or the first derivative test. Now, do we have the second derivative test sitting here? We have the second derivative. So can I just plug these numbers into the second derivative to see if they're maxes or mins? So let's plug in 1. For the second derivative test, when I take the second derivative test, 1 over 1 squared. What do you get? 1, which is positive. So if 1 gives us 1, that's positive. That means it's happy. Remember that? Which means it's a what? Min. So x equals 1 is a minimum. So your minimum is 1 comma something. Do we have to find the second piece? That blank? Do you plug it back into here? Is that okay? So when you plug it in there, y equals 1 minus ln 1. What was ln 1?
0.
Is that 0? So 1 minus 0 is 1. So there's your minimum, or a minimum. Now let's check the other one. When we plug in 0, we get 1 over 0 squared. That doesn't work, does it? Okay. It doesn't work. So that can't work for second derivative test. It doesn't mean it's not a max or min, but we have to check it. So let's actually, before we go back and do first derivative test, let's see and check to see if x equals 0 is an answer. Yeah, that's 0 minus, what's ln 0? You cannot take a natural log of 0. Do you understand this is an asymptote or a whole or something? So could it be a relative extrema? No. So what you notice is 0 does not exist. This one does not exist. When you go back and plug it into the original, that does not exist. So this one doesn't exist. Wham! But this is your minimum. Now, how do we find a point of inflection? We take this, and we're going to set that equal to 0. So where does that equal 0? When does x squared minus 0, when does x squared equal 0? When x equals 0. Okay, so this is a possible point of inflection. Does 0 work? No. That does not exist. So there are no points of inflection. Now, if that did exist, how do you find points of inflection? You check to make sure the concavity changes from positive to negative or negative to positive. You have to check to make sure the concavity is going to change. So again, let's say that was 5. You would check number 4 and 6, plug them both into the second derivative, and see if they change from negative to positive or positive to negative in the second derivative.